Welcome to the video on reciprocal trig ratios, Pythagorean identities, and inverse functions. So first we'll have our reciprocal trig ratios and Pythagorean identities. So we've kind of touched on these reciprocal trig ratios before. So our cosecant of theta is 1 over sine. So it's the reciprocal of sine. So instead of our SOHCAHTOA, our cosecant goes with sine, which is reversed of what you'd think, and it's going to be our hypotenuse over our opposite. Our secant is going to be hypotenuse over adjacent, and our cotangent is going to be adjacent over opposite. So it's just flipped from what our normal trig functions are. We have some more Pythagorean identities. So we have 1 plus tangent squared theta equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. So these will be useful for solving problems with trigonometry. Here are the graphs and domain and range for our inverse functions, for inverse sine, inverse cosine, and inverse tangent. So for inverse sine, your domain is from -1 to 1, because it's a ratio between -1 and 1. Your range is going to be from -pi/2 to pi/2. So if you look at your unit circle, your sine function will give you something between here and here, because those will be our smallest angles and give us all the different outputs of sine from -1 to 1. For cosine, your domain is from -1 to 1 again, and your range is from 0 to pi. Because to get all of our cosine values, you just need this section of the circle. And these are inverse sine and inverse cosine, so don't forget that. So our inverse tangent, our domain is -infinity to infinity. So these lines will just keep on going, and they're going to approach -pi/2 and pi/2. So our tangent, our range is the same as sine, from -pi/2 to pi/2. But our domain is -infinity to infinity because it's our hypotenuse. It's not just our x or y value. So our tangent is sine over cosine. So if our sine was something really small and our cosine was something like 1, then your tangent would be a really, really small number, like 0.001. However, if your sine of x over cosine of x is 1 over a really small number, then your tangent would be 1,000, so it would get bigger and bigger. So your tangent can be really small or really large. And it can also be negative if you put a negative in front. So that's why it's from -infinity to infinity. So here we have our first practice question with no calculator. It says, given tangent of theta equals 6 over 8, find secant theta, cosecant theta, and cotangent theta without finding theta. So our tangent of theta is 6 over 8. So if we have theta here, tangent is SOHCAHTOA, so it's going to be opposite over adjacent. So opposite over adjacent, 6 over 8. Our secant is 1 over cosine. Cosine is our CA, which is adjacent over hypotenuse. So secant will be hypotenuse over adjacent. So secant theta equals hypotenuse over adjacent. We don't know our hypotenuse yet, so we'll figure that out with Pythagorean's theorem. So 8 squared plus 6 squared equals h squared. 64 plus 36 equals h squared. 100 equals h squared. So 10 is equal to h. So this would be 10 over 8. Our cosecant theta is 1 over sine of theta. So it would be our hypotenuse over our opposite, which would be 10 over 6. And then our cotangent of theta is going to be 1 over tangent of theta. So it'll just be reversed of this. So it'll be adjacent over opposite. So 8 over 6. These can all be simplified. So we'd have 5 over 4, 5 over 3, and 4 over 3. So secant theta equals 5/4, cosecant theta equals 5/3, and cotangent theta equals 4/3. So there's the solution to this problem. Now we have our second IB practice question. It says simplify the following expression. Cosecant squared x minus cotangent squared x plus 1 minus sine squared x minus sine squared x over sine squared x. So let's start by splitting up our fraction here. So we have cosecant squared x minus cotangent squared x plus 1 minus sine squared x over sine squared x minus sine squared x over sine squared x. So this here is going to turn into 1. Our three Pythagorean identities are sine squared theta plus cosine squared theta equals 1. 1 plus tangent squared theta equals secant squared theta. And 1 plus cotangent squared theta equals cosecant squared theta. So we have a cosecant and cotangent here. So let's see if we can manipulate this form to match that. So 1 plus cotangent squared x equals cosecant squared x. And we want our cotangent and cosecant on the same side, so we'll subtract cotangent. So 1 equals cosecant squared x minus cotangent squared x. So this here is our cosecant squared x minus cotangent squared x. So that's just going to equal 1. So we have 1 plus 1 minus sine squared x over sine squared x. So our first Pythagorean identity has a sine squared x and a 1. Let's see if we can manipulate that to match our 1 minus sine squared x. So sine squared x plus cosine squared x equals 1. So if we subtract sine squared x, we get cosine squared x equals 1 minus sine squared x, which matches what we have in our equation. So that becomes cosine squared x over sine squared x minus 1. So we have 1 minus 1, so those will cancel. So then we just have cosine squared x over sine squared x, which tangent is sine over cosine, so this must be cotangent squared x. So that's what that simplifies to, is just cotangent squared x. So in summary, our reciprocal trig ratios are the cosecant of theta equals hypotenuse over opposite, our secant of theta equals hypotenuse over adjacent, our cotangent of theta equals adjacent over opposite. Our new Pythagorean identities we learned are 1 plus tangent squared theta equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. Our arc sine of x has a domain of -1 to 1 and a range of -pi/2 to pi/2. Our arc cosine of x has a domain of -1 to 1 and a range of 0 to pi. And our arc tangent has a domain of -infinity to infinity and a range of -pi/2 to pi/2. That's all for this video. Thank you for watching.